I said that actually there are two types of multiplication of vectors. Okay, so we've just looked at one. We have just looked at one. What have we just looked at? Remember, there's two names for it. Yeah, so what one? Yeah, so it's a product, but what type of product? It's either a scalar product or a dot product, because it's literally written using a dot. So u dot v. Okay, the reason why it's called scalar is because it results in a scalar. And this is particularly useful for finding the angle between the vectors. Okay? However, can anybody remember I said there was another type of product that we're going to look at? Can anybody remember which one it was? Good. Vector product or cross product. Cool. Called the cross product because it's written using a cross instead of a dot. Remember, there's two ways of writing multiplication. Yeah. It's called a vector product because it results in a vector. Okay. More specifically, it results in the perpendicular vector. Okay. So literally, if I think about two vectors, okay, let's suppose I think about two vectors in the board. Let's suppose that's u and that's v. So literally a vector facing in that direction, vector facing in that direction. The cross product of u and v would be a vector. Actually, let me swap those over, because it does matter which order. The cross product of these two vectors would be the one coming out of the board. Okay, so perpendicular, so it's literally in the direction of that pen, coming out of the board towards you, perpendicular to both of those vectors. Is that okay? Does that make sense? So it's a perpendicular vector. That's what the cross product finds. And this is literally how it works. Okay? So in this case, it's the vector coming out of the board. By the way, if you're ever not sure what order they come in, think about it in terms of your hand. Okay? So the first vector, in fact, is it left-handed or right-handed? Was it left hand?
Something like this?
Yeah, I'm pretty sure it's the left hand. Yeah, I'm pretty sure it's left-handed. So in actual fact, the u and v should be around the other way, if you want it towards you. Okay, so the vector coming towards you, but it does matter. Okay, so the vector product, if you imagine your first finger of your left hand is the u. It's always the first vector you start with. Okay, your second finger of your left hand is the v. Then the perpendicular vector would be your thumb. Okay, so it's in that order, right? So u, v, and then your thumb is the vector which you're finding. Make sense?
Yep.
Okay, good. Anyway, how do we calculate it? All you need to know is really it's a perpendicular vector. Don't worry too much about the order. How do we calculate it? Well, it's using this idea of matrices. Now, I appreciate we haven't met matrices yet. This will make more sense when we actually get round to looking at probably on Thursday. But effectively, it's using this idea of a matrix determinant, right? And it's a determinant of a 3 by 3 matrix. What I want to do is show you the formula. So let's suppose we have a vector called u, and u is u1, u2, u3. So first component of u, second component of u, third component of u, and the same for v. First component of v, second component of v, and third component of v. Okay? Well, the cross product of u and v, notice the order matters in this case. So you start with u, that's your first finger, v is your second finger, and your thing which you're finding is your thumb, okay, is given by the determinant of this matrix here. Now, matrix at the moment, all I want you to understand by it is it's just a table of numbers, okay? So you put u along the second row, working row-wise. So that'd be u1, u2, and u3. Yeah? You put v as the third row. So v1, v2, v3. So you notice the order really matters. If you were doing v.u, you would have to switch these two rows over. But because you're doing u.v, the first vector goes in the second row, the second vector goes in the third row. Okay? So what goes along the top? Well, because we're trying to find another vector, remember when we were doing scalar product, we were finding a number, okay? Because we're now trying to find a vector, we need to keep the vector there. So we're expecting a vector to come out as something I, something j, something k. So I'm going to put I, j, k. I'm going to put my unit vector along the top, or my unit vectors, basis vectors along the top. Is that okay?
Unit vectors with u and v, like
Not my unit vectors, my basis vectors, but my basis unit vectors.
Okay.
Yeah? So this, remember, corresponds to one step to the right, this corresponds to one step up, and this corresponds to one step forward.
But what do U and V then corresponds to?
U and V are the two vectors that you're trying to find the cross product of. Literally, it's your first finger, your second finger, and the thumb is the vector you're trying to find.
I see, okay.
Okay? So that's basically the matrix that you need to form, and you just need to find the determinant of it. Okay? Now, like I say, we will look more at determinants on Thursday, but for the moment, I'm just going to give you the calculation, how you actually work it out. In fact, I'm going to draw several pictures on the board. So I'm basically going to repeat this matrix 3 times. So bear with me. So I'm going to go I, J, K, and then U1, U2, U3, V1, V2, V3. Okay? And I'm going to do the same thing 3 times. Okay? Now you notice when I've written these matrices out, because I'm talking about them as a matrix, I use the curly brackets. Okay? When I've just got these straight lines, okay, it's just simply talking about determinant. Okay? So if it's a straight line, it's a determinant. If it's a curly bracket, it just means a matrix. This will become clear when we look at matrices, just bear with me for the time being. Okay? And how it works, this one's positive, this one's negative, and this one's positive again. Okay? So you go this one minus this one plus this one. And let me show you what I'm doing here. So, first things first, I'm going to take that element there and multiply by the determinant of what's left over in the bottom corner. So what I'm basically doing with this circle is I'm ruling out the rest of the row and I'm ruling out the rest of the column. So I'm ruling out all of that and I'm ruling out all of that. So what I'm left with, I then need to take the determinant of that matrix. Okay? Then I move across to the J, so I've done the I bit. Now I move across to J, which means I rule out the rest of that row and the rest of that column, and I take the determinant of the matrix which is left. Okay? So take the determinant of the matrix which is left. And then I move across to K, and I rule out the rest of that row, the rest of that column, and take the determinant of what's left. If you like, you're literally going through here, and with your pencil, you're ruling those two things out. Okay? So this reduces. I just need to find out the determinant of this matrix. Now, by definition, if I give you a 2-dimensional matrix, A, B, C, D, the determinant of this matrix should be this times this, so A times D, minus this times this, B times C. It's just a definition. Okay? So it's these elements multiplied together minus these elements multiplied together. This is given to you on the screen, on the formula sheet. Okay. So let's see how it works in action then. So we're going to take the determinant of this matrix. Well, the determinant of this matrix should be, can anybody try it? Absolutely right. U2 times V3 minus U3 multiplied by V2. And that will all eventually be multiplied by I. Okay, so it's going to be this multiplied the determinant of this. Make sense? Okay. Then I'm going to do the minus bit, because there's a minus there, and I'm just going to take the determinant of this matrix. So U1, V1, U3, V3. What's the determinant of that matrix? So U1 times V3 minus, yeah, good, U3, V1. All multiplied by that J. Okay? Plus the K multiplied by the determinant of that matrix. So what's the determinant of this matrix? Multiplied by K. Perfect. Okay? So in other words, if I want to find the cross product of these two vectors, I could just follow this formula. But I wouldn't remember that formula. Okay? I would think about it in terms of determinant of matrix. Should we do it with an example? See it in action. Okay.